What's up, guys? Hope you had a good weekend. All right, we got a lecture here today. Um, and yeah, do your best to follow along. I just would get a separate piece of paper out and just kind of do some problems with us as we go. And then there's a worksheet at the end. You don't have to do the whole worksheet because we'll tidy it up on Tuesday. Okay. So we're going to talk about single replacement reactions in particular, and we're going to actually predict them. Okay. So as you know the pattern for single replacement, all right, what has to happen is the solid metal has to be above the metal that's in solution. All right, so aqueous means it's a solution. All right, and the solid is what we would put in. So there's kind of a chart that we use for this pattern to actually happen for the metal to kick this out. And there's some rules and stuff that we'll have to follow, but basically we're going to predict this. All right, so here's the activity series, and I put this in your doc. It's also on the back side of your periodic table. All right, but basically here's what has to happen. The metal, solid metal, has to be above the metal in solution for the reaction to happen. If the solid metal is below it, it won't switch. Okay, and we get a no reaction. All right, so the solid metal has to be above the metal that's in solution for it to happen. Okay, so let's just basically take a problem here. All right, and there's 5 steps that you really have to follow. Is the lone metal solid higher than the metal that's paired? Okay, so let's look. So sodium higher than copper. So here's sodium. And is it higher than copper? Let's find out. Sure is. Okay. So sodium will switch with copper, basically, is what we're saying. So what happens is then is we always write the charge by each element. So sodium is +1. Copper says it's +2. Okay, so that's +2. And there should be 2 chlorines there. Okay, so in chlorine's -1 each of them, and I have 2 of them, so it's -2. All right, we're going to switch and flip the metals. All right, so we're going to bring one of everything. That's kind of what I always say. Even though there's 2 chlorines here, just bring one of everything over to the other side. All right, and then write the charges. Make sure the charges cancel out. So sodium's +1 and chlorine's -1, and then copper's +2 by itself. All right, and the last thing is we do is then we balance the whole thing. Okay, so all right, so I got one sodium, one copper, 2 chlorines, 1 chlorine, so I go 2, and then I would say 2 there. And that would be how you do it, okay? And I'll slow it down quite a bit when we start doing these problems. Okay, so the first thing is the lone metal higher than the paired metal. Okay, so we have to find the lone metal. Is that higher than sodium? So let's go back to our chart. Okay, so silver, Ag, is that higher? So here's silver. Is silver higher than sodium on the chart? And the answer is no. Silver is not higher than sodium. So becomes easy then because sodium says like I'm cooler than you, silver. You can't kick me out of the pool. All right? So what happens then is we just say, "Hey, no reaction. This reaction does not happen." You could put silver in sodium fluoride solution and it doesn't happen. All right? Okay, so let's do the next one. Calcium. Is calcium higher than zinc? Let's go to our chart. Is calcium higher than zinc? And the answer is yes. So they will switch. Calcium, the lone metal, is higher than zinc. All right, so what do I do then? I write the charge by each element. Calcium is +2, zinc is +2, and that's -2. How do you know those charges? Well, it says on the chart, but it also says on the periodic table too. Okay, so check, check, switch and flip the positives. All right, so I'm going to get CaO plus Zn. Okay, check. Positives always come first. Make sure the charges cancel out with the subscript. So this is where we bring the positive 2 minus 2 plus 2. So if it's paired, we have to make sure that the charge is 0. And it is. They equal each other out. So that's then that part. They cancel out. They're equal to 0. Right? And then we balance the equation. We don't really have to balance anything here because it looks like it's 1 to 1, 1 to 1, 1 to 1. So that's your final answer. This becomes what we call the aqueous solution, and then this here becomes the solid. All right? And I'll show you an example as we go, but I'm just kind of showing you that the process is the same every time. All right? Okay, so is lithium higher than magnesium? Is lithium higher than magnesium? Well, let's check. Lithium, I guarantee it's going to be higher because it's the number one on the list, is higher than magnesium. All right. So go to my problem and I say, yes, this will happen. All right. They will switch. So let's write the charges. +1, +2. And each chlorine is -1, so it's -2. Okay, so let's switch the positives. Switch and flip the metals on the right side. LiCl. Notice I didn't bring LiCl2 because we just want to bring one of each. Okay, we want to bring one of everything plus Mg. All right, did that. Okay, so make sure they cancel out now. +1, -1. That cancels out. That's +2. It's by itself. We don't have to worry about it. That's equal to 0, so we are good. Now the next thing that we do is balance the whole equation. 1 Li, 1 Li, 1 Mg, 1 Mg, 2 Cls, 2 Cls. Okay, and now what is paired is what we call the aqueous solution, and then this is called the solid solution. All right. Let me pull a video of lithium with magnesium chloride quick so you can get an idea. Well, it doesn't look like there's a video for that one. Okay, I'll find a better one. Because lithium's not stable. All right. Okay, so now we're going to get to this one. All right, so now we have this thing called a polyatomic ion on the back end. All right, which is a little bit makes things a little bit more interesting. All right, so is the lone metal higher than the paired metal? So is magnesium higher than copper? Let's find out. Magnesium, copper. Okay, so the lone metal, this is the lone, is higher than copper. They will switch. Okay. So here we go. They're going to switch. Let's write the charge by each. +2, +2. And each nitrate is -1 from the periodic table. I'll put a periodic table on. Okay. So we have it. Okay, so chlorine, or so it's nitrate, NO3, if you remember from try 1. Okay, nitrate, NO3 is -1 right there. Alrighty. Okay, so let's go back to our problem. Let's switch the positives. Now here's kind of where it gets tricky when you do polyatomics. So Mg switches with copper. So I'm going to get Mg, and then I said bring one of everything. And when we bring one of everything, we bring one whole polyatomic, NO3. Don't bring two of them, bring one of them, all right? Plus Cu, okay? Next thing would be write the charges by the metals. Let's see if it cancels out. +2, -1. So I'm going to need 2 of those. Alrighty. And then that's good. Make sure it cancels out because 2 of those at -1 is -2. That gets equal to 0. and then balance the whole equation. All right, so I got 1, 1, 1, 1, 2 of them, 2 of them. This is the aqueous solution. This is the solid solution. I know there'll be a video of this. Okay, so magnesium and copper nitrate reaction. Okay, so here we go. Here's a video of a single replacement reaction. Copper nitrate. So you got magnesium ribbon.